let's look at the final set of problems that you will encounter, and they all involve gravity, right? That's the only change from what we were doing earlier. So the first question goes, suppose a rock falls from the top of a cliff. What is its change in velocity of the rock after it has fallen 1.5 seconds? So our job is to find out what's the question asking and what information has it given us. So it's asking us to find the change in velocity. And it says that the rock has fallen for 1.5 seconds. So the change in time is 1.5 seconds. Initially looking at this problem, it doesn't seem like there's a lot of information given. But you got to realize the context of the question is given to us. It says the rock has fallen from a cliff. So there's a force of gravity being acted here, right? And there's an acceleration due to gravity, which is negative 9.8 meters per second squared, right? So now we have enough information to tackle this question. So we use our equation that relates change in velocity, I forgot the vector arrow there, to time and acceleration. So change in velocity is equal to acceleration multiplied by our change in time. We insert in the numbers. Acceleration is negative 9.8. Our time is 1.5 seconds. And we calculate. Negative 9.8 times 1.5 equals negative 14.7. Now all the numbers here have two significant figures, so our final answer is going to have two significant figures. So our change in velocity is negative 15 meters per second. Or we can say the change in velocity is 15 meters per second down. So I would like for you to try questions 2, 3, and 4 and just realize that all these are objects that are falling. So the acceleration here is the acceleration due to gravity, which is negative 9.8. So pause the video, try the question, and see if you come up with the same answers. In this question, they're asking us to find the change in velocity of a brick that is falling. So since it's falling, its acceleration is negative 9.8 meters per second, and it falls for 3.5 seconds, which is our time. So we plug these numbers into our change in velocity formula, and we find that the change in velocity is equal to negative 34.3 meters per second, or positive 34 meters per second downwards. I leave it as 2 digits for significant figures. All of our numbers are 2 digits. Our final answer is 2 digits. In this question, we're asked to find how long does it take for a ball thrown up to change its velocity from 14 meters seconds to 6.0 meters per second. So our initial velocity is 14, our final velocity is 6, and since we're going through the air, our force of gravity is negative 9.8 meters per second, right? So to find the change in time, we use our equation. Change in time is equal to velocity divided by acceleration, highlighted in green there. But before we can execute that equation, we need to know what the change in velocity is, right? We're given the initial and the final values. We plug those in to find out our change in velocity. Now we have all the information necessary. We plug in negative 8.0 for our change in velocity. We have our negative 9.8 for our acceleration. We calculate our time to be 0.816 seconds, rounding that to two significant figures. Our time is 0.82 seconds. In the final question, a rock is thrown downward at 8 meters per second and asked to find what is the final velocity after 1.5 seconds. Since it's being thrown downwards, the velocity is not 8 meters per second, but negative 8 meters per second. We fill in our variables, and so our final velocity is what we're asked to find. Acceleration is negative 9.8 from a result of gravity, and our change in time is 1.5 seconds. Now, we cannot directly find the final velocity from acceleration and time, so this is a two-step problem. First, we need to find is the change in velocity by using change in velocity is equal to acceleration times time. We plug in our numbers, we get change in velocity is negative 14.7. From this point, we can use the change in velocity is equal to final velocity minus initial velocity to find our final velocity. Right? We plug in negative 14.7 for our change, and our initial velocity is negative 8. So we have negative 14.7 is equal to VF minus negative 8, so it ends up being plus 8. We move the 8 over to the other side, and we find our final velocity to be negative 22.7. Now rounding that to 2 digits for the correct number of significant figures, our final velocity is 23 meters per second downward, or you could say negative 23 meters per second.